Welcome to How Does Bluetooth Work by Connor Hamburg and Seth Stegman. What is Bluetooth really? Well, Bluetooth is a revolutionary piece of technology that was created at a conference between three major tech companies, that being Ericsson, Nokia, and Intel. The name Bluetooth was actually coined by Intel ambassador Jim Kardak. He named it after King Harold Gormson, nicknamed Bluetooth. He united Scandinavia, and he liked it to the fact that Bluetooth unites devices together with a wireless connection. So what is Bluetooth and how does it even really work? Well, you might have noticed that when you use your headphones or your AirPods or any other Bluetooth device, that there's not a wired connection between them. Well, that's because Bluetooth establishes wireless connections between two different devices. How does it even do that? Well, Bluetooth uses something called radio waves. These radio waves are able to send energy between two different devices from the receiver and the transmitter, kind of like how a wire would have done, but without the wire. So, what is the downtrade when you do this? Well, it's the range. When you use your Bluetooth devices, it has a limited range, and that's because of the way that the radio waves work. Bluetooth and radio waves. How do they work together so seamlessly? Well, I'll let you know. Bluetooth uses a super specific type of radio wave called ultra high frequency radio waves, and it can be abbreviated as UHF. These radio waves move super fast between transmitters and receivers. That's so fast that it's almost seamless, and it mimics how a wired device would be. So how are these radio waves created? Well, they're created between oscillating electrons within your phone, and these oscillating electrons gather speed and they send each other to a different receiver super fast. Right here in this graph, we can see the transmitter oscillates the electrons and sends them off to the receiver, and it's not wired and it's able to create a seamless connection. Ultra high frequency radio waves. How do they work? Well, I'll tell you all you need to know. Ultra high frequency radio waves are electromagnetic waves that only travel in short ranges. They're extremely fast, and approximately they can travel up to 2.4 billion waves per second. Whew, that's pretty fast. In this graph here, we can see how they're made. These electrons travel back and forth between this wire, slowly picking up speed as they oscillate. This creates this electromagnetic field and creates all the magic that you see in the high-frequency radio waves. These radio waves are extremely versatile, and you can see them in all forms of life. Every time you use your GPS, you're using ultra-high-frequency radio waves. Every time you turn on your microwave, you're using ultra-high-frequency radio waves. So why isn't Bluetooth on your phone super long range, and why can't you connect with devices hundreds of miles away? Well, that's because of a little thing called path loss. Path loss is the reduction of energy as a radio wave propagates over a super large distance. In the top right, you can see a complicated math equation that details exactly how you can calculate path loss. So how do you get around path loss? Well, the short answer is you really can't. The only way to get around path loss is just by injecting more energy into the equation. So by the time after path loss has affected the radio waves, you still have just a little bit of energy left to get to the receiver. That is exactly how Bluetooth 5 in the long-range mode used in Bluetooth 5 operates. It injects more energy at the time that the radio wave is released, so you have just enough energy for it to be received by the receiver. In this short video, you can see a visualized version of path loss, and you can see exactly how it looks. This red area signifies the source of the signal and exactly where it's its strongest. Around it, you can see how it propagates and slowly gets weaker. How are these high-frequency radio waves measured? And how is your Bluetooth measured overall? Well, they're measured in something called decibel milliwatts. Your Wi-Fi and your Bluetooth is directly measured in these. Decibel milliwatts are able to be directly converted to milliwatts. In the top right, you can see a chart showing exactly the conversion between decibel milliwatts and milliwatts. And on the bottom, you can see an equation to convert decibel milliwatts directly to milliwatts and vice versa. Decibel milliwatts are a little weird. They're measured in negative numbers, and the closer to 0 decibel milliwatts is the better the connection is. Negative 30 is typically what your perfect connection will be on your phone and your laptop, while negative 70 is what is considered completely disconnected on any devices. But why should you even care about Bluetooth in the first place, and how does it even affect you? Well, society is inevitably developing towards a wireless future. If you've ever heard about the Neuralink, created by Tesla CEO Elon Musk, that is a completely wireless piece of technology that he plans to implant into people's brains sometime in the near future. If you ever heard about the Apple Vision Pro, well, that is just a prototype. Apple chief executive Tim Cook said that the Vision Pro is only the beginning of their computing process and will eventually blend the digital and physical world through wireless technology. Now, about radio waves. They're incredibly important. They're used in military combat and homeland defense to intercept missiles from other countries. Radio waves are also used for research by NASA to map out star systems, find new galaxies, and even give us a better understanding of the universe entirely. Thank you for listening.